Hello again. I've been really lucky to work with this next speaker for the past 5 years. He's an orchestra musician in a symphony by night. He finds time somehow to work on the production of the conference badge this year and many of the past years. He is also the editor-in-chief of Hackaday. Let's welcome to the Hackaday Super Conference stage, Mike Szczys.
Oh my gosh, SuperCon number 5? How is that possible? So, first of all, thank you for being here. I know Sunday morning is a hard time to get out of bed because I had to do it myself, and I said, oh my God, I got to give a long talk today. But this is the most exciting time of year because so many people that I love seeing and love hanging around with and am inspired by end up at the SuperCon. And it's really special to be seeing behind the scenes what happens. We have a wonderful staff of people. There isn't necessarily one central command, but there's a lot of people who know what they're doing, and when problems come up, they know how to solve them and have made this every year even better than the last. I wonder if we could just give a round of applause for everyone that has helped organize and run SuperCon this year. Oh, I have 2 identical looking controllers. I think this is this one. All right, so I have the pleasure of talking about Hackaday a lot, and has anyone here ever found themselves struggling to explain to someone what Hackaday is? Like, it's a weird thing, right? So I often go for Hackaday being a tech news website because I'm really invested in the writing that we do. I'm editor-in-chief of Hackaday.com, but it's so much more than that. And sometimes we talk about Hackaday being like a global virtual hackerspace, so a place that you can go and meet with a lot of other technical people that are doing things that are the same as what you're doing and doing things that inspire you and help you learn other things. You could look at it as a project hosting website. You could look at it as a place that we go and congregate around different ideas. I really like to think of it as, like, through the Ask Hackaday articles, if you need to know, like, collectively, what do we think about something? Like, what are the different ways to look at this that I'm just not seeing? What are the common ways that people have overcome it? I think that's a really interesting thing to tap into. Oops. Oh, I just gave away the reveal slide. So looking at the ability of people to build really high-end things, I think can be really inspiring, and then going and seeing that they're having the same problems that you are, and they're walking the same path, and that these things don't just magic themselves into existence. I think it's, the social media culture, it's really easy to look and see like amazing project after amazing project after amazing project and not see all of the stuff that went in behind that. And so I really like being within the Hackaday community and telling that story of like, oh, this thing totally didn't work and I wasted all my time on it and I had to spin boards 5 times and it was a lot of money and the project came in 5 months late and oh, that totally happens. And so looking into this and explaining what Hackaday is, I think Elliot Williams has the best quote, which is that Hackaday is the common link in the collective brain. So whenever there's something that needs to be done and you need to find a way to get over this problem that you're having, oftentimes you're going to find people are have crossroads that go through Hackaday. Like you end up finding a new part and you're like, oh, this new part's awesome, but I can't get it working. And you go and you Google it and you're like, oh, there's a Hackaday article on it, or there's a Hackaday project on it, or this person that I met at the SuperCon wrote about it on their site, or they work for that company and I actually have the inside track to it. So I really look at Hackaday when you describe what it is. It's a community that already existed. It's the community that's right here. And our role as Hackaday is to not screw that up, to facilitate that and to say, let's celebrate all these people and move them forward, and let's do it in a way that we can all get behind and that welcomes more people into it. I think we've done a lot of great things this year, and I wanted to go over a few of them before I get into the bulk of the talk. Possibly the thing I'm the most excited about is we have a mobile view that is totally awesome for reading articles. So where before we had the wide view and you'd have to double tap over here and it would get really big. Now we have a responsive view. I spend the majority of my time reading on the back end, editing, but whenever I'm not there, I'm on my phone, as are like more than 50% of our traffic. And boy, having a mobile view now is an excellent experience. I'm very happy about that. But not just on Hackaday.com, we have a mobile app for Hackaday.io as well, and this is super cool because I've actually stopped traveling with the DSLR at this point because the camera in my pocket is just so much better. And so I'm sure, like all of you, when you're sitting at the bench and working on something, you're snapping pictures constantly. And then you have to do this dance of like, how do I get the picture from my phone onto my project? And it's, you know, you could use a USB cable, and then you have to figure out the image that has the weird name on it, and you're like, which image is it? Or you can do the other one that I often do that I hate, which is, okay, this got uploaded to the cloud, right? Didn't it? Didn't it? And then you go and look, and you're like, why isn't it uploaded to the cloud? So you can snap images, you can put captions on them and upload them directly to your Hackaday.io projects. I think the biggest power of Hackaday.io is those project logs, so you can document it along the way, because once again, I like to not just see the finished project. Definitely check that one out. Oh, has my cursor been going crazy the whole time? Oh, you're welcome. All right. I think I turned the cursor off. Has anyone here heard the Hackaday podcast? Woo! So Elliot and I did this really foolish thing in December. We're like, let's do a year in review podcast. And it got a lot of warm response, and I thank you for everyone that has encouraged us through it. We committed to doing a podcast every single week, and we've done it, I think, every single week but 2 weeks. Is Elliot here right now? He was here before. I think he's looking around somewhere. Elliot spent an amazing amount of time editing this thing, and he has a really good ear for the audio side of things, and so it sounds great because of Elliot's hard work. We're publishing about 300 articles per month. It's difficult to keep up. I love doing it, but I understand there are other things than Hackaday in your lives. This is a great way to spend about an hour a week catching up on, a dozen, 16, 17-ish articles, and just kind of looking. We go over the things that were written about in Hackaday, but also just the wider hacker sphere, what's going on, and really love doing that. The Hack Chats are something we do weekly on Hackaday.io, and we bring in experts from industry to talk about what they're doing. And I think it's really special because oftentimes you just don't get this view, this under-the-hood view of what people are doing. And some of my favorite ones that Dan Maloney lined up this year, Dana Lewis came in and hosted a Hack Chat. She is the one who launched the it's Hacking Diabetes. So it's the Open Artificial Pancreas project for people that are type 1 diabetes and need an insulin pump and need better options and more options that might be available commercially. There's a great one on photography. There's one on CubeSats. Quinn Dunkey, if you know her from a few of the articles that she's on the Hackaday, also has a fantastic channel on machining, a YouTube channel on machining. Came in and talked about setting up machines in your shop. I know Dan's always looking for people to host that, so if you have ideas or if you are interested in hosting, please reach out to him. I'm going to give your email address out, Dan, I'm sorry. Dan Maloney at hackaday.com. Oh, there he is right there. He's a great guy. Talk to him. Ton of fun there. Also, we have wonderful contests. We have this really big contest you might have heard of last night called the Hackaday Prize, what wonderful winners last night. But we run other contests throughout the year, and two of them that really caught my eye and did way better than I thought they would, really amazed me, were the Circuit Sculpture Contest and the Beautiful Hardware Contest. So the Beautiful Hardware Contest, I didn't think it would be very interesting because the constraints were so simple. It was like, okay, take a cool picture of your hardware. Like that's just, how do you even start there? But of course, there are people who are trying to take amazing images, and so these are three of the winners from that contest. This is, look at that. That's electronics. So and then these are from the Circuit Sculpture Contest, and that's Kelly Heaton's, and I see Kelly right there. And it's just amazing. We take things that could just be really boring, green, square circuit boards and turn them into something that far transcends what their original use was meant to be or their original design was meant to be. And I really love those. So go check out those two contests. Let's see. I'm missing a slide. All right, well, let's go to that slide. So I would like to talk a little bit about all of the editorial we've done this year and all of the 15 years of Hackaday. But one thing that keeps striking me is the amazing growth that we've seen and the ability to just pursue our mission a lot more closely over the last 6 years. And that started when Supplyframe bought Hackaday and started making it making a real point of supporting the community. So one of the most important things to me is that Supplyframe has safeguarded Hackaday's editorial independence. So we are we have all the freedom that we want to pursue topics in the way that we think that they should be pursued, and we don't feel pressure there. And that should not be understated. That is something that is very special in the world today. But the other thing is they have had amazing support for the community, from building out the Hackaday IO website so we have a place virtually to get together, to launching the Hackaday Prize and other contests that try and promote engineering, and making it a priority to have live events like the Hackaday Super Conference, events all over the world, and also by sponsoring events that Supplyframe doesn't produce that also support the community. And I just wanted to take a moment to say thank you to Supplyframe for that. Everything that Hackaday has been doing in the last 6 years wouldn't be possible without it. So let's give them a round of applause. All right. Okay, so this might get a little long because I went back and looked at all the articles we wrote for the last year, and it's amazing. So the first thing is, if you haven't been reading the Friday 7 a.m. Pacific article slot for the last 15 weeks or so, you should, because Jonathan Bennett has been throwing down an amazing series with the Week in Security. I think, as, I don't know what you want to call us, computer people, everyone in our lives looks to us to explain the things that they're hearing about, and a lot of times it's these security vulnerabilities, and they're wondering, like, what is that? And the thing is, we need to be informed about that, and it's hard to keep up with. This is a really good consumable way every week to get like the little overview, like what do you need to know? And I mean, Jonathan's also really good at putting the breadcrumbs in there, like if you need to know deeper about this, where do you go for it? So I think that's excellent. Take a look at it. Our editorial goals this year, one of the biggest ones is to take a look at what the wider media is covering and pull out those engineering stories that aren't being told. It's happened all kinds of times this year, but I pulled out one that kind of starts at the beginning of the year. You may have heard that the media was talking about these hypersonic weapons, and they were saying hypersonic, they were saying scramjet, they were saying all these words, and they weren't really explaining any of it. And Tom Nardi got onto that one and wrote a really long article and realized that all these terms were getting mixed up, and they really didn't have anything to do with each other. So he wrote this story, which is really about like a projectile launch that's put out from high altitude and can be guided and is a hypersonic craft, but then also realized that the scramjet's a completely different thing, and it's an engine style that operates at really high speeds, so high you can't really have a turbine in there, and it's like the geometry of how the air path moves makes it work. And so he looked at the history behind that and why it's so hard. I thought that was a good engineering story. And then you may have heard of radiation alarms going off from some accident in northern Russia, and people are guessing that this is actually a flying missile that is powered by some kind of nuclear reactor. And again, I think this is also Tom. So when Tom started looking into this, he realized this is not a new idea. This has been around a long time, and kind of dug up the story of testing after the Second World War in the United States, and how they figured out it was probably a bad idea to have a flying reactor. And then if you think about things like the Fukushima disaster, there's a lot of question marks that came up about, like, how are we monitoring radiation? How can we be sure that we're getting the information about it? And so Lewin Day picked up on this and said, oh, we've seen all of these air quality monitors and environmental monitors and radiation monitor systems being put out on the internet, networks that people can build and put their own nodes out. And so he went and looked up all of the networks that he could, and found that at least from these networks, they confirmed that what was being reported, that this was not a hazard in places outside of the immediate area, were true. And I think it's just an interesting, the first time at least that I've seen that we've had a problem, and these open source networks have been used to kind of confirm that the official information that we're getting is right. And that's kind of a powerful thing. I like that. Of course, looking at things like this car is no longer being sold. How interesting is that? Well, not very interesting, except for the technology that went into it and the choices that went into it should have made it a really popular, I guess, all gas alternative. And Roger Chang dug into that and said, what choices in the design and what choices in the way that it was rolled out and the time period it was rolled out made this successful or not successful? Dan Maloney has been doing the $50 ham column. So if you're into amateur radio, he's trying to build inexpensive things that let you kind of like level up your skills in amateur radio. And while he was working on this story in Ohio came out that the whole neighborhood couldn't get the key fob to unlock their car to work. And he's like, what's all that? So you think about it, okay, well, there's, somebody's jamming, and that's regulated, so you should like roll up to their house and slap the handcuffs on, right? Well, first of all, whose house is it? And the municipality was thinking about like shutting off power to like one block at a time to try and find out where this problem was. And of course, the great story here is the amateur radio community is self-policing. So a ham got out and basically did like a fox hunt to find where this interference is coming from. Ended up knocking on the door of the house, and the guy's like, oh yeah, I built my own home automation system. I didn't know that it was a problem. And the ham goes and says, well, look, this is what's wrong. Let's fix this together. And instead of going to jail, you have people who are now able to say, oh, watch out for this. This is an issue. And it ends up becoming a public service rather than chasing after problem children, I guess. I don't know if you heard of this guy, Elon Musk, but he makes really big claims. And he said, I bought this company, and it's going to let you control everything with your mind. And Maya Posh is like, whoa, 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 whoa. Let's just unpack that for a minute. And she went and looked at the company and the technology they have for brain-computer interfaces and said, there is novel things here, but let's really talk about a serious timeline and let's kind of ground these claims so that we don't have unrealistic expectations. And I think controlling those expectations, especially in a wider consumer electronics market, is really important. Ted Yapo. Ted, are you here right now? I think Ted's badge hacking. This is an insanely good article. This may be my favorite article of the decade. Go and look at this. Actually, it's not. His next one might be. So if you remember when LED light bulbs came out, I was not a huge fan of compact fluorescent because they have to like warm up. And I'm like, LED. They're on immediately. They're great. They're low power. They're wonderful. And they last 100,000 hours. It says right on the package. And then who here had a light bulb burn out in like 6 months or a couple of years? Like everyone. And you're like, oh, I threw that package away. How am I going to get this? So he dug into it and said, why were they making those claims? What's actually causing these light bulbs to die? Why is it when I put a new light bulb next to one of my old light bulbs, they are not the same brightness anymore? Kind of unpacked some of the marketing BS that goes into those and gave us a dose of reality. They're still great. Use these bulbs. Don't go back to incandescent. He also did another one that said, I had these 30-year-old rolls of SMD parts, and I can't get solder to reflow onto them. They just kind of like jump off the board. And did a bunch of side-by-side testing, some of my favorite things of these types of Ted's articles, and figured out you could sand the oxide layer off of the solder and get it to work just by rubbing it on a piece of paper. So as long as you don't have hundreds of these to populate, you can hand rework them. We've been following stories that are near and dear to us. So a lot of Raspberry Pi stories. Did anybody here have a 3.3 volt rail die on their Raspberry Pi 3 Plus? No, nobody. That's great. So it turns out on the pin header, if you accidentally shorted 2 pins, you'd kill the 3.3 volt rail. And I think the cool thing about these next few slides is Raspberry Pi has been really cool about acknowledging this and talking about why the design is wrong and what they're going to do about it. So another one is they had the Raspberry Pi 4 came out this year, and they said, we started hearing these reports that if you used a charging cable, if you used a really nice, expensive charging cable, it wouldn't work. And Maya Posh dug into that and looked at exactly the USB-C spec and said, oh, it's these E-marked cables where they actually have a chip in either end of the cable, and they don't work because the specification is not right. And Roger Chang jumped on that and said, oh, you know what? It's not just the Raspberry Pi. Like, this is a really hard specification to get into. And the reason I'm not trying to drag Raspberry Pi through the mud. We love Raspberry Pi. It's really cool to have inexpensive single-board Linux computers. But I think the fact that USB-C is what we're moving towards and that it's hard to implement, so hard that an established company that has a lot of products out in the field is, fell afoul of it, means we need to tell a better story of like, where are the tested and proven designs? How do you test your equipment to make sure it's compliant? And can we make these things available so that we don't just make this mistake over and over and over again? And I think that's one of the places that Hackaday can really excel, is by highlighting proven designs and promoting, sharing your testing protocols openly. I think the space race is one of the greatest ways to get people excited about science. And so I like to see that going on again. We've been doing a lot of coverage of that. I hope you're enjoying that. I certainly am. It's not the first time we've had a space race, though. We had one, a half a century ago, and there's still a ton of stories to tell about that. I just pulled this one out. We've continued to do our profiles in science, which are finding, technologists and mathematicians and chemists that have moved technology forward. This is a great one about the V2 rocket, the Redstone program, which could not have gotten into orbit without a new formulation for fuel. And it was a person from my home state of North Dakota, grew up in a tiny town, I don't know, like 25 people, that came up with this formulation. We are really happy to have a ton of deep experience on Hackaday. And so every time a new programming language comes out, I'm like, okay, who has some experience in this programming language and can dig into it and tell me what it's all about, because I'm interested, but I don't have the background. And so if you want to use V, who's heard of V? A few people, but now you can learn a lot more about it because of Ben James. It's not just that language. Maya Posh is, she must have my number because I have committed all of the sins on buffer overflows in C that you could possibly commit. I don't know why that termination character in the C string arrays, it gets me every time. But if I switched over to Ada, it's so tightly typed that it would never let you do that. You can't buffer overflow on it. So if you have problems in C and you want the compiler to really rein you in, Maya will convince you that Ada is the place to go. And the new C standard has been formalized. Do you all know what that means? No, I'm sure not. So go and check out Sven Gregory. He said, hey, here's the new things that are interesting and some of the things that aren't interesting, but at least you can stay in the know. We have a lot of writers writing every single month, and I really like that because we have people that are experts in certain different areas and allows us to really, for them it's just normal stuff, but for us we don't get to look at it very much. And so Brian Cockfield actually works on Power Grid and did a bunch of articles this year just looking at, like, for this one's like, what are the poles made of, why are they as tall as they are, and how do they leverage insulators to keep the high voltage apart, what kind of equipment do they use to step up and step down for those transmissions, but also when current events things happen, like there was a huge power outage in all of Argentina and also part of Paraguay and Uruguay. And the reporting, the official announcements of what happened coming out of there were like really sparse, but because of his experience, he was able to like fill in all the blanks on it, really tell a comprehensive story. Once again, something that was reported in the wider news, but it was reported as there was a power outage, and now there's not. And he actually looked at it and said, this is, things like cold starting facilities, like how hard is it to start up power generation once it's stopped? Like that's a really interesting story, and we're happy to have him write about it. All right. I probably have like 10 more slides on this, but I'm going to move on just for time. Oh yeah, we have plenty of time, don't worry. So Hackaday started on September 5th of 2004 was the first article published on Hackaday. And I think it's amazing to look back. We wrote an article, and unfortunately you just cannot cover in one article all the things that happened in 15 years. So I thought, hey, State of the Hackaday, I'll cover all the things that happened in 15 years. No, that's really hard too. So being someone that is always jealous when speakers have really good stats and graphs and stuff, I was like, I can pull some stats. So I have a fun little stat thing. So 5,500 days, we wrote almost 35,000 articles. We have received over 900,000 comments. It's amazing. And I'm always floored how many times we write something and someone will be in the comments that said, I worked on that program, or I work at that company, or that's what I do on my day job, and gives all kinds of interesting insight to that. Going back to my, the wider Hackaday community is there just waiting for some way to cross paths. And, when you know something, you want to share your knowledge. I think that's really cool. One of the things I do hear from people, though, is like, back when Hackaday wrote one article a day, that was the real Hackaday. And so I looked into that and I said, how long was that? When did we actually write one Hackaday? Because it certainly has not been for a while. So I pulled every single day for 15 years. And you can see the most we ever published was 16 in one day. And we had a good run here, but there's some noise in there. So this is the one baseline. And we get a little bit above that. So I thought, okay, if we do months by year instead, we get a little better thing there. And then I said, okay, years. So we do have a pretty close baseline there on years. And I said, all right, well, let's actually look at the number of distinct days. So this is 1,073 days out of that 5,500 days we published exactly one article. And you can see this is more what we're at right now. We publish 8 every weekend, and we publish somewhere between 10, 11, or 12 on the weekdays, and that's kind of the modern Hackaday, but it still didn't quite mean much to me as far as the stats go. So I looked at baseball, and they have an on-base percentage, right? And so that's really what we need. So I put together the solo hack percentage, and you can see that in 2004, we had a perfect solo hack percentage. Every one of those days, September through December, exactly 1 hack per day. But by 2015, less than half of the days were 1 hack day. So our solo hack percentage was very low. And by 2009, it's almost gone. So we like to write articles. I started reading in 2005, and I read every single word in the Hackaday article, and I clicked through and read every single word in the articles that they were running, and I learned just a ton from that. And yet I was still left wanting more. And so I think if you're into hardware especially, but really just the wider technology in general, you'd like to be entertained and you'd like to find things to write. And so that's why we're running more than 1 hack a day, is people are interested in new stuff. Going and looking at the number of authors, I think it's no surprise that as we published more articles, we had more authors. At this point, we're up to about 20 to 30, maybe 25 to 30 authors per month that give us that wide different background. But what was really interesting to me, and Elliot and I disagree on this, I think this is a really low number, but in 15 years, 35,000 articles, we've only ever had 157 published authors. That's really incredible. And these people generally have better things to do with their lives. They have really interesting jobs, they're doing important things, and they make time to write for Hackaday because they also come from the Hackaday community. They also know what it is to have this form of entertainment and this form of education, and really want to give back. So I'd just like to recognize these 157 people and give them a big round of applause. So in looking at our 15 years, the thing that really struck us is the way that the technology, especially the hardware, has changed. So it used to be a lot more difficult. I'd like to say kids these days have it so easy, except for it's not just kids. We all benefit from this. It changed so quickly that it didn't take an entire generation to get to this point. But if you go back to 2008, which is still not even when we started, about 4 years later, and look at what it took to build a little robot with Wi-Fi. Who here owned the WRT54 router? Who here hacked on it in some way, shape, or form, right? So if you're someone that hacked on it, you will recognize right here the serial, the DB6, DB9, DB something connector that breaks out the serial port that gives you interactivity with it. But you had to have a whole router on there, and then that means you have to power a whole router, and there were just a lot of problems that went into it. You go to 2009, and this is a Arduino form factor Wemo board. So it's a ESP8266, I believe. You get it for a few dollars. It's going to have the same kind of motor driver. Of course, motor drivers are easier to get these days. But look over here. You have an entire user interface that you don't have to build yourself, that everyone that you could possibly put this robot's hand into already has. And in this case, if you look really close on the screen, it's using the Google Assistant voice commands. So we have like a voice-controlled robot over Wi-Fi for way less than we did when we were putting a router on it. Unbelievable. It, of course, isn't just Wi-Fi that we're interested in. People wanted to put cellular on it, and that goes way back as well. But it used to be you had a whole cell phone. So you'd put your whole cell phone on the robot, and then, of course, what's the problem with putting a cell phone on the robot? How do you connect your hardware to it, right? And who here really misses the days of USB on the go? Oh, what a horrible standard. I mean, there were some good things. I remember I had the yo-yo board that you could connect to. It like broke it out, and that was okay, but it still was just a fight to get that stuff to happen. Well, we fast forward to 2019, and Carrie Sharfglass wrote an article called Choosing the Goldilocks Cell Module. And so it's not just like, here's the thing to put cell on it, but it's like, here's all of the different choices that you have that you can buy right now for still pretty inexpensive and get it to work on your device. That's an amazing chasm to come in just 11 years. This one is an autonomous robot from 2006, so they did exist before, dot.com 4.0 or whatever we're at. Some of the things that are interesting about this, look at all of the batteries. I guess it's really low resolution in there. I mean, cameras weren't that good in 2006 either. It was crazy. So there's just a ton of AA batteries on this thing all over the place. And then I'm pretty sure this is a GPS module, and I'm not sure this is maybe Wi-Fi, something. Anyway, it was difficult to do these things. This is the Donkey Car. I saw this at Maker Faire Bay Area in 2017. It's an autonomous driving vehicle powered by a Raspberry Pi 3, so like $35 Linux computer, right? It has this camera right here, which the board is made to work with the camera. This car is actually looking at the track ahead of it on the camera and making driving choices based on that on this little computer. I mean, I know you live in the same future that I do, but it's incredible to think about how far we've come on these things. The other thing is look down here. You got rid of all of those AA batteries, and you just put a tight little lithium pack on there. And so you have to look into it and say, all right, the 18650, that cell that we love to use for lithium batteries these days, that I went and looked at, it started being produced in the 90s and being put into laptop batteries. And so we do see a ton of projects, but they're usually pulling laptop batteries out, and then you have to be like, okay, how am I going to not blow this battery up when I charge it, and how do I charge it? And like, you spend half your time on your project getting the battery to work, and now we can just go, because of the RC field, and buy a drone battery that has all kinds of power density in it, and you can buy a charger that you're pretty sure is not going to catch it on fire, and in general be a lot safer than I have been around some of those boosted boards or the electric skateboards when somebody punctured some cells. That's some scary stuff. Watch out for that. All right, and who thought you would have been able to build your own machine tool? Like, that is something 10 years ago, I mean, really, 10 years ago you would have thought, I can't get into that, that's too tough. And, well, I guess more than 10 years, somewhere in there. So we had RepRap come along, and RepRap really revolutionized that and said, you know what, let's put motors on stuff and let's make it possible for people to use them and build high precision things. But still, you had to like get into that community and hope you could convince someone to send you the original parts, or you could do, I think they called them rep straps, where you tried to like hand make those parts to the point where you could then print something better and build your machine. Well, now, I hope you've seen Joshua Vasquez's Jubilee tool changing application. We have extruded rail, super easy to get. We have, what do they call these? Linear bearings? Linear rails? Something like this. Precision rails right there. You have the ability to get very high power and high precision motors for incredibly low price. You have good examples on 3D printed connectors for them and 3D printed jigs and how to build that. It's like not just the hardware that goes into this, but like the entire ecosystem of how do you build things that are going to work well and don't have backlash in them and don't have flex. And it's really amazing to see that. It's come so far. I am looking at where we're going from here, and it's hard to imagine because these advancements seem to keep accelerating. But I think the place that we're at right now is kind of like, I was walking here this morning and talking to someone about robotics they were doing, and I said it's kind of like hash include robot. Like at that point, it really is getting to the point where you like have an existing design and you wish it to be part of your project, and it can. This is one of my favorites you can find on Hackaday.io. These are time-of-flight sensors, so really inexpensive because of economies of scale, and they've put 3 of these on this little piece of circular PCB that spins and created a very low-cost but still totally usable LiDAR called X-LiDAR. That's incredible. I look at what got us to this point, and it was good ideas. So, somebody spent a lot of time just making this AVR chip talk to this existing unit, and you can bet that like getting the libraries to work on this was non-trivial. But everyone looked at it and said, that's what I want. I want GPS on this. I want a geocaching box. Remember those, geocaching? That was a good time. I want to do some geocaching, and I need GPS on that. And boy, I wish I could do this, but that seems like a lot of work. And so someone comes along and says, that is a lot of work. Maybe we should make that into a module that you can just slap on top of your microcontroller breakout board. And we'll also give you a library that will just work when you use it. And decade of that does a lot and brings us really a long way, to the point where we're getting there in software as well. If you think about what Arduino did, Arduino came in and said, you shouldn't have to be a toolchain expert. You shouldn't have to be able to write your own make files in order to do something on a microcontroller. And you shouldn't have to be, a computer scientist to connect a temperature sensor up to something and then be able to echo that out on the serial port. And a lot of people said, this isn't real embedded systems and you should be counting cycles. But the thing is, it opened up the economy to a lot more people who wouldn't have gotten into it. And what that does is you identify people who are going to be microcontroller experts that maybe wouldn't have been exposed to it. And those people come in and are like, oh, this library is kind of janky, I wish it was better. And then they contribute back to the open source. And so what we end up is getting like exponential growth on the ability to build good products and to make them work for everyone. I think we're getting to another kind of fast forward moment with that. And I think it's in the MicroPython and of course the CircuitPython, which is based on that lineage. Because when Arduino first came in, it was running on like the ATmega 8. It wasn't super fast, it didn't have a ton of flash space. But then the embedded systems caught up, and now like the Teensy 4 was released as like a 600 megahertz clock in there. Like it's amazing, and so you don't even notice any kind of like wrapper overhead on that anymore. Now MicroPython, it has a definite speed hit to it, but think of how many more people have been exposed to Python than have been exposed to C++. And so I just took two examples. OpenCM3 is like an open source library for the STM32 and a lot of other controllers. This is an example that you can't read at all, sorry about that, of using a USB mouse and USB keyboard with those devices. And there's like a bunch of magic numbers in there. So like GPIO numbers and just stuff that you're like, what is this? Okay, I'll copy it and make it work. And then MicroPython comes along and they're like, oh, hey, here is CDC, HSC, and CDC HID. It's like one-liners that turn those on and turn those off. And somebody else is taking care of all those magic numbers under the hood. That's really transformative because it is like software include to make your hardware work. And I think that the future is going to see that just about anyone becomes a hardware person and just about any hardware person becomes a software person. I think these are benefits for all. A microcosm of this is the badge that we saw at the Hackaday Super Conference. So it's based on an FPGA, and as you can see, the FPGA becomes whatever hardware you want. So there's a couple of RISC-V cores. You throw them in there, you do your RISC-V stuff, you don't really think about it. Once it's up and running, you can make the interface, any interfaces that you want to work on that. But even beyond this, it's only becoming, I think, widely adopted at this point outside of just industry that's building products that has FPGAs in it because we have a fully open source tool chain on that. And I think the work that has gone in by the people that are contributing to those projects cannot be understated. With vendor tools, it's difficult to custom hook them into your own processes. So if you want to script things, if you want to do anything other than what's traditionally been imagined on the FPGA, it's difficult to do with vendor tools. When you open it up to the open source tools, it's your playground. You can do whatever you want. Get under the hood and build that. And that's just going to allow people to innovate. And I think we're going to see these in a ton more products because of it, and I'm really excited about that. You shouldn't be locked into whatever your product functionality is just because it was shipped out the door. We have the ability now to change things in the field, and that's where we're moving. The other thing on the Hackaday Super Conference badge is distributed engineering team, and I was particularly happy to hear the Axiom team accept their award for the Hackaday Prize last night because they said, this is the first time the three of us have met. And I knew I had this slide in here, and I'm like, oh, I hope I'm not just full of BS. But this badge team is from all over the world, and we put together a Hackaday project on Hackaday.io that had a chat room in there, and you go and look at people getting to know each other and working through problems and talking about what's going on with all the code. If you're working in an office with other people, chances are you're already interacting with them virtually. You're on a Slack channel or a Discord channel, and yeah, you do see them in person. But I think the default is I can always get to them through the screen and the keyboard. And so to remove the close proximity physically, I think is not as foreign as it was 5 years ago, and definitely not as it was 10 years ago. And so Hackaday.io is a great place to work on these distributed projects and find people from your own teams. But I think just in general, look outside of who is right next to you or who is across the street from you, because I know my next door neighbor doesn't want to talk about watchdog timers, but I want to talk about watchdog timers, and so I'm always looking for someone. I'll be out back after this if you're a watchdog timer aficionado. So let's talk about the threats, the things we have to watch out for moving forward into the future. Let me just go back. If you show someone this, and then you say, you should try build your own electronics too. Oof, boy, this is not that hard, but it is not easy. And so when Arduino came out and we're like, you can blink an LED, and someone looks at a blinking LED and says, I can do that, and even if they've never, touched a C++ before, like, they can figure out how to do it. If you say, you could put a RISC-V core on your Game Boy shaped badge and you can make that work, that is a much bigger hill to climb. And so we need to be very careful that we're not making magic and amazing things look like that's the only thing that you can do. And this goes back to my earlier comment on social media and always seeing finished projects. Like, celebrate people blinking an LED, celebrate people writing their first line of code. Make sure we're telling that story, that you can get into it, and that things like this Hackaday badge are easy in the way that a lot of people before us have proved every step along the way. And what we can do is go and gather all that stuff up, but it doesn't have to be that big of a thing for you the first time out of the gate. I think we really need to normalize the fact that this can be entertainment. You don't have to do this like, oh, are you doing this in order to get into college? Are you doing this to get funding for your startup? It doesn't have to be. I'm doing this because I don't want to watch the horrible talent show at 7 p.m. on broadcast television, right? Like, I'm getting to the point where I can't watch the TV anymore because it doesn't entertain me. And so I think a lot of people are getting to that point too. And so let's tell the story that you can entertain yourself, maybe learn something at the same time, but have some fun, and don't put the pressure on yourself that I have to achieve all of those shiny pictures on Twitter or even finish the project. Like, just playing with it and figuring out, is it the thing for me, is worth it, is worth your time. And I've said this before, and I'm happy to say it again. As we level up in skills and as we learn things and get better at things, we have a higher and higher obligation to pass that on and to share that with other people and make sure that people feel like they're being welcomed and that each small achievement is being celebrated. So be inclusive with your knowledge, pass your knowledge on, publish it openly, and make it something that everyone can benefit from. I think that's what Hackaday is all about, and that hasn't changed over the 15 years, except for it's become easier to share those things, it's become easier to get people excited about it, it's become easier for each and every one of you to have an impact on the world and on individuals. And we're going to keep doing that with every waking breath, and I hope you will join us. Thank you so much.